Hi everybody. This video today we're going to talk about basically an equation review. I know you all know how to solve equations, so I'm just going to touch on some of the more, I don't know, complicated parts maybe that people have. So I'm going to start off with distributive property. There are two methods for the distributive property. Most people know the first method, and that is you distribute and you multiply them out. And so if I do that here, I'm going to get negative 30x plus 48 is equal to 168. Now I just want to solve my equation. I'm going to subtract 48 from both sides, and that gives me negative 30x equals 120. I divide by negative 30, and I get x equals negative 4. That is what most of us do for distribution, and that works. There's nothing wrong with that. However, I want you to know that there is another thing that you can do instead, and that's what I'm going to show you over here, is that sometimes instead of distributing, sometimes it's easier to divide by whatever that number is instead. So I'm going to divide by 2 because 2 is outside the parentheses here. So rather than distributing it, I'm going to divide it first. Sometimes that makes the problem actually a lot easier, and especially if that outside number is like a fraction or just, I don't know, a little more confusing. So when I divide this, of course 100 divided by 2 is 50, and the 2 over the 2 here cancel, and all I'm left with is 8y over minus 6. Now that is a lot easier because it's a lot smaller. So now I'm just going to add 6 to both sides, and now this is a really easy problem to solve. Divide by 8, and I get y equals 7, or 7 equals y is my answer. Now you might ask, well, why did you do that? Why didn't you just distribute it? You can. Let's say that I had distributed it instead. Then that would give me 16y minus 12. I would add 12 to both sides. And now I'm having to divide 112 divided by 16. Well, you know what? I'm kind of lazy, and I don't know what 112 divided by 16 is without a calculator, and I don't feel like I have a calculator. So this way, I could do totally with mental math. It was just easier for me. So does distribution work when you get the right answer? Yes, but sometimes it's easier to do dividing instead. Okay, let's move on to the next section. The next section is on combining like terms. I know you all know how to combine like terms. I'm just going to point out a couple differences between number 3 and number 4. On number 3, if you look where the equal sign is, the two variables, a, are both on the left-hand side. If you look at example number 4, the variable, the n, is on the left and on the right. And so there's two different ways that you should do each kind of problem. If it's set up this way, there's one way to do it. If it's set up this way, there's a different way to do it. If it's over here where they're both on the same side, then yes, you need to combine like terms. And so negative 6a plus a is negative 5a. And of course I have my negative 2 on the other side. I'm going to subtract my 3 and divide by negative 5, and I get a equals 1. So if it's on the same side of the equal sign, you combine like terms, and then you just solve it out. If they are on different sides of the equal sign, then you do it a little bit differently. I need to gather my terms, my like terms on the same side. So I need to gather my variables, my n's, on the same side. So I'm going to add my 2n. And when you do that, you can do it a variety of ways, but that's the way I'm going to do it because number 1, I like to avoid negatives. Number 2, I prefer to have my variable on the left. So when I do this now, I get negative 1 plus 3n is equal to 5. I need to add my 1 to both sides, and I get 3n equals 6. So I divide by 3, and I get n equals 2. All right, neither one of those was a difficult problem. I just wanted to show you the difference in how you do it between if they're on the same side as each other versus if they are on different sides from each other. Okay, the next section, denominators. What do we do with denominators? How do we solve an equation with denominators? There are a lot of different ways you can do it. You could combine these first. I wouldn't, because then I would have a messy fraction, and that just seems like it's a big mess. Instead, what I recommend you do is you multiply by the denominator. So in this case, both of these fractions have a denominator of 5. And so I can call it 5 over 1, or I can just call it 5, whatever, but I can multiply both sides times 5 to get rid of the denominator. This, when I do this, these 5s basically cancel each other out and leave me with 16 over here. On this side, I do need to distribute, and that gives me a negative 5x minus, and here the 5 cancels again, so I get 3x. Now this is going to be a lot easier to solve than if I had left that fraction in there. I combine those like terms, I divide by negative 8, and I get negative 2 is equal to x. So when you have a denominator, the easiest thing to do is to multiply by that denominator to get rid of the fractions. I would say pause the video here and write that down on the margin. Next problem, similar. It looks a little bit different. The difference is this had a fraction on both sides. This one just has one on one side. Also, this fraction is like the whole thing over 2. You still do the same thing. We talked about multiplying by the denominator. So we're going to multiply times 2 on both sides. And on the right, I might call it 2 over 1. On the left, I think we're okay with just a 2. I multiply that out. That gives me an 18. On the right-hand side, the 2's cancel. And so I get negative 1 plus n. I need to add that 1 to both sides. And so I get n equals 19, or 19 equals n. Of course, on any of these, you should be able to plug it back in to check your answer. I didn't take the time to do that in the video, but you can always plug it back in to check your answer. Okay, next section is on unusual answers. What do I mean by unusual answers? Well, by unusual answers, I mean things like 0, no solution, and infinite solutions. And so, again, I know that you've done these before, but it probably is worth a little bit of review. Okay, I have a problem here with the distribution. I could distribute or I could divide, and you can do it either way. I'm going to show you the division just so that we have another problem that we've practiced that on. You could distribute, absolutely. I'm just going to show you how to do it this way again. When I divide this, negative 21, negative 7 is 3, and then plus 7 and negative 7, divide that, and I get negative 1n, or you could just say 3 minus n. On this side, the negative 7's cancel, and I'm left with a 6n plus 3. Okay, need to solve this. I'm going to subtract 6n from both sides. I was a little ahead of myself there. And that gives me 3 minus 7n is equal to 3. That looked kind of strange, interesting. We'll see what goes next. Okay, I'm going to subtract 3, subtract 3 from both sides. And so now I have negative 7n is equal to 0. Now, at that point, some people get a little freaked out. It's okay. Don't worry about that. It will all work out in the end, believe me. We divide by 7, and that gives me n equals 0 divided by negative 7. 0 divided by negative 7 is 0. Guess what? That is an okay answer. It's okay to have 0 as an answer. And if you're not sure, you can always plug it back in. If I plug in 0 here, that would give me negative 21 plus 0. If I plug it in over here, I get a 0 here, so that would be 3, so that's negative 21. Negative 21 equals negative 21. That works. 0 is an acceptable answer. You can have an answer of 0. Some people think you can't, and they get freaked out. Do not get freaked out by 0. There is nothing wrong with 0. Okay, next one. Again, I could divide. I'm not going to, because look, if I divided this one, I'd get a fraction. I don't want a fraction, so I'm not going to divide. Instead, I'm going to distribute. So I get 7x plus 7 is equal to 5 plus 7x. I need to subtract 7x from both sides. Okay, what happens when I do that? Suddenly, I don't have any variables. All my variables are gone, and I have 7 equals 5. Does 7 equal 5? No, it does not. So my answer is no solution. You have to say no solution. You can't just leave it at 7 equals 5. That's not the answer. The answer is no solution. Now, what does that mean? That means there is no number you could possibly plug in there that would make it true. You can try it. You can try to plug in a 0. You can try a 1. You can try a 10. You can try a 35, whatever. There is no number that you could plug in that would make it true. It's a messed up equation. Number 9. All right, 2y minus 2y is 0. What? 0 equals 0? That doesn't make any sense. Well, no, it doesn't, or it does. Don't know how you want to decide on that. But what this means is infinite solutions, or the way some people say it is they say all real numbers. And you could say it either way. What this means is any number in the whole world that you plugged in there would be true. You could plug in a 5. You could plug it in a -9. You could plug it in a 73. Any number you plugged in will make it true. So all real numbers will work in this. There are infinite solutions. And I would take either one of these wording, and either one of those is fine. Okay, last problem. Again, you could divide. I'm going to go ahead and multiply. No reason, just you can do it either way. This is going to give me a -8n plus 20 is equal to -8n minus 20. That's funny. Even when I said it out loud, it should have sounded strange to you. Because when I add 8n to both sides, it drops off, and I have 20 is equal to -20. Does 20 equal -20? No, it doesn't. So that is not true. That means this is a no solution problem. Okay, in the margin, take a second to pause the video and write down a couple of these things. Actually, write down all of these things. The first, x equals 0 is an okay answer. You can have 0. That works. That is an actual answer. Next one, if you have the same number equal to itself, that means we have infinite solutions. That was like this one, the 0 equals 0. If you have 0 equals 0, that means all real numbers or infinite solutions. You could have 5 equals 5, you could have 10 equals 10, whatever. That would mean infinite solutions. And finally, if you have a false statement, like 7 equals 5 or 20 equals -20, that means no solution. Okay, we will continue to work on equations. I know you all are good at equations, but these are some of the tricky ones, and we'll work on these in class.